Recording started.
And I will turn it over to Dr. Lockaby. Graham, it's all yours.
Thank you very much, Bill, and I appreciate all of you joining the webinar this afternoon. I'm looking forward to this. We've got a very diverse group geographically in terms of background, and so that's great. I think we're going to have a good discussion. What I'd like to talk about, discuss with you this afternoon, is the influence of forest cover loss and land use change on water. And so these are, most of my examples are going to be from the southeastern United States, but I emphasize that these are national trends, global trends, and so I think, in my opinion, most of what I say would be applicable to any humid region. And so with that, let me see if we can move through this a bit. Bear with me just a second. Okay. Three objectives, general objectives for this afternoon. I want to talk about the drivers of change across the southeastern landscape. The southeast has always been in transition from the time of European settlement to a great deal of the landscape being put into agriculture, then reforested, and now the current trend in many areas in the southeast and many areas in the United States is urbanization replacing forest. And so the second objective relates to this. When this occurs, there are alterations in hydrology, biogeochemistry, and biology that occur. Some of these very pronounced. And then the final objective, we have to ask the so what question. So these alterations occur, what does this imply for human well-being? So put us all on the same page, some information that many of you know. If you look at it, at the projected population increases, and I think this is through 2030, in several different regions in the United States, you see that anticipated to be quite an influx of people into the South. And so with that increase in population, there are many implications associated with that. Having just a little bit of trouble flipping slides. This is a image from a report that I'd urge all of you to take a look at if this is down your alley, the Southern Forest Futures Report. This was a regional effort by the U.S. Forest Service, which really contains some great information. These are projections, I believe, through 2050 of the potential for increased population change. The bluer the color on the map, the greater the potential population increase. And so what we see in the South is if we go to Texas and we look around cities like Houston and Dallas, we see a lot of potential population increases there. We move around the coastline, get to about Baton Rouge and New Orleans, a lot of population probably going to expand there. Around most of the Gulf Coast, particularly in Florida, and then all up the eastern seaboard, into North Carolina and Virginia, and again, this is very common throughout the eastern United States. Okay, and so what does that mean? Well, obviously, with people along comes a great deal of urbanization. And this image, which is also from Southern Forest Futures, the greener the color, the greater the degree of urbanization. These are county level data. So we see pretty much the same pattern that we saw before. Around large cities, greater expansion, a lot of urbanization around the seacoast in the southeast, and then particularly the Piedmont in the Appalachians. A lot of anticipated urbanization going on there. And so one point I want to stress, and this gets at the third objective, well, you know, when this happens and there are implications for water, what does this mean for people? I want to stress even in the southeast, which is a place we normally don't worry about water supply, that there's a close linkage between water availability for people and the extent of forest cover or the loss of forest cover. And so in the southeast, you know, we never think about this. In a lot of the eastern U.S., it's a common topic out west. But in the southeast, the drought of, I guess we would say, 06, 07 really brought this home. Had a very pronounced drought during that period. And people began to actually talk about the topic, and so you know, that was a very good thing, because it's something that's going to reoccur in the southeast. We have these types of events about every 8 to 9 years, and so there begin to be ramifications. Some of them not major, but for example, here in the Atlanta paper, admonition to turn off sprinklers. There was a great deal of concern about the water supply for Atlanta. Similar concerns in Birmingham, where they were actually concerned about the level of water availability in some of the chief reservoirs for the city. And so the Birmingham Water Works, in talking with them during this period, and particularly in a little bit wetter year, they indicated that they often get enough water, they just can't capture it. And so some of the instability that comes when forests are removed or at the heart of this issue. So you can't capture the water, it's moving off too fast, and the results are to the solution for that is either to have retained a lot of green space in the watersheds or to build a reservoir. In the case of the reservoir that Birmingham was looking at, it was $500 to $600 million. And so the lack of water supply during that drought was brought about by a combination of factors: increased per capita use, increased population, increased development, three things that are not likely to dissipate. So those factors, as we're going to talk in detail in a bit, drive decreases in water quality and quantity. Those will intensify, and we can expect about once a decade for this situation to be exacerbated by drought. So the situation, the setup, the scenario that's going to make us vulnerable to drought is going to increase. So we'll be increasingly vulnerable to this type of thing. So in the long term, again back to Southern Forest Futures, these are outputs from 4 climate models that were used in that publication. And so you can look at the models have different projections in terms of precipitation for the southern United States. In Model A, you see it's the driest of the models. The browner the color, the greater the decrease in precipitation. And so pretty much throughout the southeast, things get much drier, particularly in Texas there. Model B is probably the wettest of the model, although you see a large area in the inland part of the south, the center of the south, anticipated to get drier. Same thing for Model C, and then again in D, it's pretty dry as well. So the takeaway point from this is that regardless of which model you pick, a very large area in the southeast is anticipated to become drier. So you superimpose this onto that scenario that we were just talking about, and then the outlook is a bit serious. So the key drivers that we're looking at here are population increases, increased urbanization, and the periodic stressor of drought, plus a long-term increase in decrease in population. So as you heard in webinar 1, or if you were not in webinar 1, there's a great deal of literature that indicates that in watersheds that have heavy forest cover, and by heavy I'm talking, I don't know, 60, 70 and up % of the watershed being forested, that those watersheds are associated with stable hydrology. That's a very critical concept right there, as well as clean water. And so this is pretty much true for managed or unmanaged forest. If they're managed forest, it does necessitate that BMPs are followed. So, as the greatest primary cause of forest loss in the South right now is urbanization. So when this occurs, what changes occur? Well, the hydrology changes a great deal in terms of discharge and hydrograph, which I'll show you in a moment, and many other things. And the water quality degrades rapidly. If you're looking for water quality issues associated with land use, urban is your winner, or I guess the loser, as you could look at. Very, very severe problems there. Quick degradation, using almost any metric that you can come up with. So let's look at the hydrologic changes in just a bit more detail. If we look in the upper left here, this is a situation with natural ground cover, 100% forest. And so in this generalization, we've got about 40% evapotranspiration, 10% runoff, not very much, and then about 50% infiltration between shallow and deep infiltration. So this infiltration is a big deal. This allows the water to move into the soil slowly for storage. It loses energy there, and it replenishes slowly and in a stable manner stream velocity and discharge. If we move to the right, the upper right, we get about 10 to 20% of impervious surface. Throughout the presentation, the metric I'm going to use for urbanization is impervious surface because it is a causal factor. It directly causes changes in hydrology and water quality. And so that simply means pavement or any surface that water cannot penetrate. And so we see we get about 10 to 20% impervious surface. That doesn't sound like a lot. But for hydrologic changes, that's about the threshold where you begin to see some significant shifts. And so you can see a decrease in evapotranspiration because there's not quite as much vegetation there. Doubling of runoff. Now this is a typical trend of urbanization, and a slight decrease in infiltration. So the hydrologic cycle is beginning to shift. And if we go down to the lower left with 35 to 50% impervious surface, which is quite a lot, that's an area where we're seeing major changes. Again, evapotranspiration has dropped to 35%, and the tripling of runoff from 10 to 30% runoff. And again, a significant decrease in infiltration. So again, we're shifting towards more importance on runoff, less on infiltration, and moving over to the right. If you look at 75 to 100% impervious, well, we're never really rare that we get to 100, but that's essentially like the mid part of a large city. Evapotranspiration is down again. Runoff is greatly increased, and infiltration is now only 15%, where it was 50% in the low impervious situation. So I'm talking a lot about impervious surface. Let me give you an idea of what we mean. By 40 to 55%, this aerial image of the Auburn campus, if you can spot, there's a lot of green space there. Although, again, 40 to 50% is a bunch, and you're going to see some changes there in hydrology. You're going to see a lot of changes in water quality. But there is a fair amount of green space available. Over on the right, this is downtown Atlanta, midtown Atlanta, about 80 to 90% impervious. And so that's about as high as you're going to go. So just to give you an idea of what we're talking about there with impervious surface. Now these are two hydrographs, which I think some of you probably saw. I think Jim Bowes may have shown these briefly in the first webinar, but we'll spend some more time on them. These are from some of our data that were collected along a land use gradient from Columbus, Georgia towards Atlanta. And so the graphs are a graph of daily discharge of streams per hectare versus time. And so the upper graph is in a watershed that's predominantly forested. And so these illustrate very well the idea of stable and unstable hydrology. If we look at the dark pattern in the upper graph, which is the precipitation, you see, not surprisingly, it's very spiky, which is always the case in a year with normal rainfall. But you see that the red line pattern above that, which is discharge, or the amount of water that's moving in the stream, is fairly flat. And so what's happening here, the rain's coming down, a lot of it's infiltrating, it's being stored in the soil, and you don't see a strong reaction in terms of the volume of water in the stream until you get over here just after February, and this looks like a very large rainfall event, which does boost discharge noticeably. And so you contrast this with the lower graph. Again, we have our spiky same rainfall pattern, but the red pattern is dramatically different. You see very strong, very rapid changes in stream discharge. It's a very spiky type of a pattern that's formed. And so what's happening is the rain's falling. You've got a lot of it moving into the runoff flux. And so it's moving right into the stream, causing the discharge to fluctuate a great deal. It goes up very quickly, and as the rain eases off, it drops very quickly, and also velocity is picking up. So this is what I mean by loss of stability when we convert from forest to urban. And so in tandem with those changes in the hydrographs, we have higher velocities, increased storm flow, which is, many of you are fully aware, is a big problem in urban areas. A lot of problems created with that. Reduced base flow. What base flow is the amount of flow in a stream coming out of a watershed during a period when there's not a lot of rain. And so in a forested watershed, you have that water trickling out, moving out into the stream that's been stored in the soil from the higher infiltration. You don't have much infiltration, much storage in the soil in an urban setting, and so base flow tends to be lower, which could lead to problems for aquatic organisms. And then also increased discharge, which we've already talked about. So those are some of the changes that occur. And you begin to see this fairly quickly as you move into the 10 to 20% impervious surface zone. Now, there's also ramifications of this down basin. So if you have, like we're looking at Georgia here with the Altamaha River Basin, and so we have a lot of urbanization around Atlanta, as we saw in those earlier figures. Well, there's impacts of that down the basin associated with those changes in velocity and higher discharge that occur in the upper basin. And so the same thing's true of any large river basin. And so if we look at that just a bit more closely, what we see is the urban streams, because of the higher velocity, tend to be very in size. They cut down into the stream banks and export a lot of material out of the stream bed, and they get further and further in size. This is not the best illustration of that. There's many times it's much deeper than this. Now, down basin, what's the significance of this? There's a so what question. Well, forested floodplains, one of their chief values to society is known as the kidney function. When floodwaters move into a forested floodplain, they move out across the floodplain during sheet flow, during a flood event, and a lot of sediment and other pollutants drops out. And so you have situations like this. A lot of the nutrients in the water drop out, and any type of pollutant that's associated with that's attached to the sediment is removed from the water. So this is a big deal. This is one way that floodplains benefit society a great deal, by pollutant removal. So this is what disappears as the stream incisement leads to separation between the floodplain and the stream, breaking the linkage between the aquatic and the terrestrial part of the system. So that potentially has significant ramifications. Now also, moving back to the city, again, a function of loss of stable hydrology in much of the eastern United States and probably elsewhere as well. So this old infrastructure, which was called combined stormwater sewer systems. And so this was a bad idea that somebody had long ago, but it's been installed in many cities. Basically, during a big rain event, a lot of that runoff moves into the storm drains, and when it overflows, it goes into the sewers. And so it's not at all uncommon to see a manhole cover and a sewer blown off. And so that's really bad. When that happens, you get to situations like this, where you have the stream becomes literally dilute sewage. This is not a rare occurrence, I'm sad to say. This is very common. And sometimes when I give a presentation like this, people will say, yeah, now that you mention this, I recall smelling a bit of sewage odor after a rain near my house. And so this is a problem. Again, if you had more stable hydrology, if there was more green space, more forest vegetation retained, this would not happen to the same extent. But now replacing that infrastructure is very expensive. Atlanta did that. They replaced a lot of theirs, cost between 5 and 6 billion, not million, but billion to do that. But there were demonstrated health risks to it. And so the sad thing is that you have, this is not just major cities, but small towns like Auburn, or it occurs there as well. You have streams flowing through residential neighborhoods that have very high fecal coliform counts. Again, the loss of the stable forest hydrology is a primary driver of this, and so it's an unusual situation. My background was sampling water quality in more forested settings, and we moved into the cities about 10 years ago and started this work, and we were really shocked. But you hear about the filthy streets of London back in 1400 and whatever. And so people emptying chamber pots out the windows, and you think, well, wow, that was really bad. Those people were very ignorant. Well, maybe we haven't progressed so far as we like to think, but this is a big deal, and we'll return to this topic when we talk about health ramifications. So water availability. Again, until about 06, 07, you didn't hear much about this in the southeast. It's primarily a western topic where the rainfall is often very limiting. But if you think back to that stability in the hydrograph, and these are two relationships between percent of total flow available for withdrawal and different withdrawal rates for 2 watersheds in Birmingham, Alabama. And so if we look at this, the solid line is for the forested watershed, and you see that it's always well above the dashed line, which is for the urban. And the reason for this is the water's moving at higher velocity. A lot of it moves before you can capture it. Just what the Birmingham Waterworks people told me. And so your solution to this that most cities go with is to build another reservoir. But again, you're talking significant expenses associated with that. And so, when people argue that, well, you should retain more green space, more forest vegetation in developments, the reasons given are usually for aesthetics, which are very important, and don't get me wrong, but there are also some other reasons which are extremely important when we're talking about water supply for human consumption. Okay, so let's summarize here a minute. The hydrologic impacts of forest to urban conversion: increased runoff, reduced infiltration, increased steam discharge and velocity, reduced base flow, inside stream channels, disconnections between the stream and the riparian zones, which implies reduced pollutant filtration, and then reduced water availability for consumption unless the urbanization is coupled with ample reservoirs. And so this is a good place to pause and answer any questions about hydrologic impacts, anything there that's unclear. I see that we have Gisun who's a renowned forest hydrologist with the Forest Service who knows a lot about this topic. I don't know if Guy, if you'd like to make a comment, or anybody who has a question, this is a good time to speak up.
Thank you, Graham. And I'll go ahead and moderate any questions or comments. Again, if you'd like to use the chat room, it's as simple as typing in a quick question or comment down below there. We can also attempt to hand the microphone off to you if you'd like to do that, if you feel like you've got a working microphone. So we'll just give a couple of seconds here to see if anybody has a comment. Okay, well, I think you must have everybody pretty well up to speed so far, Graham, so you can go ahead and continue. And don't forget to click back on your microphone if you're ready to speak.
Okay, sorry about that. Yeah, if there are no questions, we'll move into the next topic associated with the webinar, which is the impacts of forest to urban conversion on water quality. And so these impacts are very pronounced, very clear-cut, very well documented in the literature, probably more so than the hydrology, although there's been quite a bit of work on that as well. So in these data are from an article that Guy Soon and I wrote, a book chapter actually, where we reviewed the literature. And so typically in literature you see sedimenting, once you increase impervious surface, I would say beyond about 20%, you see sediment increases of maybe 2 to 5-fold, nitrate increases. Nitrate tracks impervious surface very closely because nitrate molecule moves readily with water. 2 to 7-fold increases in nitrate, phosphorus 1 to 9-fold increase, fecal coliform 4 to 10-fold, and E. coli 6-fold. So big changes in the quality of water once you begin to convert this. And so I should make a distinction at this point between an urbanized watershed and a developing watershed. So an urbanized would be something that's already developed and for whatever length of time. Developing would be something, a watershed that's under development at the present time. And so these effects are not like you sometimes see after a forest harvest. If you see a small spike in sediment or something like that after a clear cut, that dissipates rapidly as the site becomes revegetated and stabilizes again. Unfortunately, with urbanization, these impacts don't go away. If it's urbanized 50 years, you may still be seeing these impacts. And they do tend to occur quickly during the development stage. And so, now the sediment, I want to mention this, there's 2 ways that sediment can increase in a stream and associated with urbanization. In the southeast and a lot of, again, the eastern U.S., there's a lot of what we call legacy sediment in streams from old ag practices back in the 19th century that were not very conservation oriented. And so a tremendous amount of erosion. I think the southeastern Piedmont has been estimated to have decreased in depth or in height by 12 to 18 inches just in erosion. And so this is what we see here. This student is holding his hand at the interface between the original floodplain and the overlying legacy sediment. And so this stream here has cut down into the original floodplain, but in many cases the stream is still perched up in the legacy sediment. So along comes urbanization and you get this rapid increase in velocity and discharge. It can resuspend a lot of the sediment that's associated with the legacy, churn it up again. It also is moving probably sediment in from outside the channel as well. And so the end result is that both of these can be detrimental to aquatic organisms. But you do tend to see a lot of sediment increases with urbanization. And this tends to be magnified in physiographic regions that have more slope. In other words, you see more in the Piedmont of the southeast than the coastal plain, which is flatter. Okay, as I said, nitrate goes up quite a bit after urbanization, conversion from forest. And so not only does it go up, but the chemistry of the stream becomes less stable. And so what we're looking at here is the range of annual medians for nitrate. Now, the difference between the max and the min within a year versus percent forest cover in a watershed. And so you can see the legend. There's 3 urban sites up here to the upper left, and what that indicates is that not only are the medians higher, but the difference between the max and the min is greater, and so you've got a lot of fluctuations in water chemistry, similar to what you have with that hydrograph, great fluctuations in discharge, and so that's a little more strenuous, a little more stressful for aquatic organisms, fish. And as you move down to the lower right, you come into some of the rural areas, which are pasture essentially in this study. And then down to the lowest right, you have managed and unmanaged forests. Again, the unmanaged forests with BMPs are very stable and have very clean water as well. And so you can see the contrast as you move from high percent forest to fairly low percent. So sadly, that's not where it stops. There's all kind of stuff in water, urban water. Pesticides in one study present in 1/3 urban streams. Pharmaceuticals, 80 to 90% of urban streams. And yeah, I don't have a medical background. I'm a wetland biogeochemist. But I tell people, I've seen the data. And so probably, the CDC wouldn't back me up on this, but we see elevations in a lot of these things in small towns, big cities. And so I tell them, if you take your children to a park in a town or city, don't let them go in the water. It's not a question of should they get in a stream. You're asking yourself, do I want my child exposed to elevated fecal coliform, which I can almost guarantee you is in that stream. And so it's again, we're not talking about exceptions to any rules here. We're talking about the common scenario, unfortunately. So, summary of water quality impacts. We'll go over this and then again offer an opportunity for questions. Very, very commonly the rule is increased concentrations and loads of sediment, nutrients, and other contaminants. The sediment increases vary with physiography, meaning there would be more in the Piedmont versus coastal plain, but the urban impact for nutrients dominates physiography. In other words, you may see just as much of an increase in nitrate in the coastal plain as in the Appalachian Mountains, or vice versa. The urban impact is so strong for nutrients that it overwhelms physiography. And with the threshold of impact is a little bit lower for nutrients than it is for hydrology. It's maybe 5 to 10%. So it doesn't take much impervious surface before you begin to trend into an area you don't want to go. So, with that, are there any questions associated with the water quality discussion?
Okay, now's the time to speak if you've got a question. Got the chat room down there open and ready to go. Quiet group today, Graham. It's all yours.
Okay, we'll move ahead to the next topic, which is the biotic integrity of the stream biology. And so I'm getting a signal from somebody. Is that a question? Maybe not. I'm not sure what that was. Anyway,
I think that yeah, Danny may have had a question. I'm not sure where it went to. So if you can ask your question in the chat box, that'd be great. And I'll just keep an eye on that, Graham, if you want to keep talking.
All right. What we see with urbanization impacts on the stream biology is we see increased temperature, often because we're not utilizing as much soil water and refurbishing the discharge, the level in the stream. It's been moved across perhaps warm impervious surface or open to more sunlight. Decreased dissolved oxygen. When you increase the temperature of the water is able to retain less dissolved oxygen, which can have negative ramifications for aquatic biota. Certainly going to see increased nutrients, which affects aquatic biota, and burial loss of substrate. Some of the aquatic inverts, the insects that require substrate for their reproduction, some of that can be eradicated as well. The results of this, I'm seeing, am I getting some questions popping up? Seeing some chatter about the chat room here. Maybe not. The results of this are increase in number of tolerant species that can tolerate a great deal of more stress than others. Decreases in sensitive species. Now, the rainbow trout wouldn't do very well in these situations. And decreases in biodiversity, decreases in species richness associated with urbanization. And so, again, some results of some research. Decreased mussel abundance in a study in Georgia and Alabama. And then decreased fish health. This is very interesting. Again, these are some photos that came out of some of the work on that land use gradient in the Georgia Piedmont. These are catfish that came out of urban streams. As you can see on the upper catfish, there's a large gap in the belly of the fish, which the aquatic biologist who gave me these slides interpreted that as a lesion. And on the lower catfish, you can see the yellow arrows pointing to some spots around the head, which they felt were tumors. And so, in any event, I think we probably agree that these do not look particularly healthy. These are, I believe these are chubs, which came out of not an urbanized site, but a stream in a watershed that was still developing. And again, you can see these tumors or whatever these are, these swellings on the chubs, and again, indications that perhaps these are not the most healthy fish in the world. Now, back to the fecal coliform issue. Everybody remembers Hurricane Katrina and the devastation in New Orleans. And so there was a lot of sewage overflow there. And I recall watching CNN during that terrible event. And the commentator made the comment, the water that's flowing through the streets is very, very filthy. In some cases, it has as much as 15,000 colonies of fecal coliform per 100 mils. Okay, that's a lot. But I want to show you what naturally occurs in a situation where we've lost forest cover and gone to urban. And so these are 6 samplings from streams in and around Columbus, Georgia. And so you see that the land use was urban for all of them. One was still developing. The fecal coliform counts are all well above the Hurricane Katrina levels in New Orleans. So no disaster. This is just, you know, a normal year. And so again, this is the type of thing that we risk when you know, we don't retain forest cover, or allow the hydrology to become very unstable. And this again is a function of unstable hydrology. So let me stop there and ask any questions about biotic impacts, and then we're going to move to the final topic. What is known about permeable concrete? That's a very good example, and that can certainly mitigate a lot of these impacts. I'm thinking the problem with it is the cost. And so that's a very good point. I'm stressing retention of trees and green space, but also the use of materials like permeable concrete would certainly help a great deal as well. Anything that can reduce the runoff and maintain infiltration. A second question, are stream buffers enough to help this problem? or is it more of an urbanization problem? The buffers can certainly help, but it depends on if you've got stormwater drains, or you've got drainages along streets that bypass buffers, and you've got all this water going into the stream. If the water is routed in such a way that it goes through the buffer, they would help quite a bit. In many cases, the engineering design is to bypass that and just get it off of the developed area, away from the homes and yards, as quickly as possible, and sometimes that takes it directly to the stream. Any other questions? Okay, that's great. Okay, now I want to really dig in here on that third general objective, so what? All this is going on. Is there a relationship between forest and human health? Well, the answer is yes. We often think of this in terms of prevention of obesity, which is a very serious problem, and that's a good thing. Apparently the presence of forests can help with that through increasing motivation to walk and to exercise. But I'm going to talk about some other aspects that are, again, driven by the two factors here: loss of the stable forest hydrology and rapid degradation of water quality. And so again, it's linked to hydrology and pollutant inputs, and it's primarily manifested in urbanizing landscapes. So back to this scenario that we talked about briefly. This is another manhole cover that's been blown off. This is about 20 feet away from a stream. And so you get the material coming out of the combined stormwater sewer overflow. I want to emphasize that sewage movement into the stream is not completely associated with CSOs, is what we call these things. It can occur in a variety of ways, and so if in Atlanta, for example, where they fixed a lot of the infrastructure, you can still expect to see elevated fecal coliform in places, but possibly not as high, not those tremendous levels that we talked about earlier. Okay, so again, we've got these things going on in the streams. Places like Columbus do a great job of cleaning up the water before it goes back into the Chattahoochee. But in many cities, there's no cleaning of the water before it hits the water treatment plant. And so you've got these streams running through residential areas. So what you have, and unless children have changed a lot from when I was small, children like to play in water. You've got some very dirty streams there. People often let their pets play in the water, then they hug and pet their dogs and whatnot. And so it just stands to reason that if you come into contact with higher levels of fecal coliform, you might get sick. Well, we talked about to the CDC about this. And so they don't disagree, but conjecture and proof are two different things. And so this is a hard item to study. EPA and CDC have done studies where they have a captured audience, like at a beach or a park, where you've got parents bringing in children through a gate, and they can identify these people, ask their permission to collect some information from them. As they leave, they may say, okay, did you get in the water? How long were you in the water? And can we follow up with you later? And so the effects of this type of exposure, there have been demonstrations in those situations of increases in diarrhea, increases in school absenteeism. But for a stream running through a residential area, it's much tougher. You don't know who's getting in the water. You don't know how long they were in there. If they get diarrhea later, diarrhea can be caused by a lot of things other than dirty water. And so this was something that we backed away from studying based on advice from the CDC. It was just hard to make that epidemiological link. So looking at something else that was in the news, excuse me just one moment, let me take a sip of water. In looking at something in the news last summer, West Nile virus. The mosquitoes associated with West Nile like to have dirty water. And so they often occur near cities. And so West Nile, either you have the disease or you don't. And so this is much more straightforward from an epidemiological standpoint. And again, I have no medical background, but you know, it's nice that you can find medical people who are willing to work with foresters, and so that helps make that linkage. So West Nile virus, is this related to forest loss? This is a question we're asking now and actually studying. Some of the characteristics that are risk factors are the type of forest you have, the amount of forest, of course, urban hydrology, corvid habitat. Corvids are a group of birds like blue jays and crows, which are a reservoir for the West Nile. It actually kills them. And socioeconomics. But the Culex mosquitoes, which carry West Nile, they're the vectors. Their habitat is better, higher quality habitat in dirty water. And so if you have the urban hydrology, where there's this rapid increase in discharge, you have flooding, water pools around the edges of the streams, and it's very dirty water, you know, the chances are that that's a potential problem. And so just a quick look at some data which seem to support this notion. This figure represents a graph of the frequency of occurrence of Culex species, those that carry West Nile. This data is from Atlanta. And so you can see the red outline here in the middle of the city of Atlanta, and the dark triangles are over here on the far right, you can make those out, are the location of CSOs in Atlanta. So what you see, there's a spatial association, a spatial clustering between the location of CSOs and the occurrence of this type of mosquito. And so it may not be total CSOs. Some neighborhoods, poor neighborhoods, tend to have worse water quality in general, apart from the CSOs, and so that may be a factor as well. But we can take this a little closer to humans with the number of corvid, dead crows, and blue jays. And so the darker brown here on the left indicates, you know, higher occurrence of higher death rate for corvids and a higher occurrence of West Nile virus. And so again, we see association a little bit less associated with the CSOs. And then finally, let's take it to people in this last figure, where again you see on the left-hand figure of the city, you see the dark brown there in the center. And so that was where some of the sewage overflow was associated, and a higher number of human cases. So again, what many of us are interested in is establishing a link between forest loss, loss of the stable hydrology, and human illness. Because you know, with West Nile last year, dengue fever has been reported in Texas and Florida, and so again, with some of the future projections, the diseases of this sort are thought to become more common. But if they're associated with anything like the loss of forest, we'd like to know. And there's a good reason to suspect that may be the case, but again, we've yet to show the proof of that, but are working on it. So, quick summary of biological impacts, and any questions here. Decreased diversity, decreases in sensitive species, increases in tolerant species, and big increases in pathogenic bacteria, and risk to human health. So if you have any questions related to biological impacts or anything about the webinar in general, I'm all ears.
Great, thank you, Graham. And I believe there is a question. I'm not sure if you did have a chance to answer that one yet.
I've said it's what solutions do you suggest other than more forest? Well, you know, this is kind of what you asked me to steer away from, but this does suggest that, you know, the notion of water quality service in forest is, you know, a more serious concept than maybe we heretofore realized. I mean, there's engineering solutions to some of these things. Certainly water availability, if you spend a lot of money, you can cover those bases. but again, you know, it would be interesting to try if we had some retention of forest. And it's not just, this is more finely tuned than just, you know, increase the percent forest in the watershed. You know, there are areas that give you more bang for your buck. If you retain forest in location A in the watershed, that may be a lot more meaningful than location B. But there are ways to prioritize those. And so it would be very interesting to see some of that explored. And I've got another question here. What are some examples of the most common pharmaceutical contaminants? Hormones would be a good example. The materials in birth control pills, one that pop up quite commonly. There have been some suggestions that has had widespread effects on people. But you name it, anything that somebody flushes down a toilet or pours down a drain. Okay, got some more questions coming. This is good. And the part per thousand slides available to get information on studies. Yeah, their literature cited on these slides, and I think somewhere on the portal I sent in a list of those citations. And so you can either look at those or you contact me, and I'll give you all the information that I have. Okay. Based on the example locations that you provide, are there water quality violations in 303D listed streams according to the EPA? Answer is yes. Second question, have they factored litter into, it just jumped. Factored litter into the study. Many of the West Nile vectors are container breeders. Absolutely. This comes on socioeconomic. And so when we go in to look at this, one of the landscape descriptors are open containers, tires, abandoned tires in yards. And so this is what we bring to the table. We're good at describing landscapes, and then the medical people keep us from going too far on that interpretation. So let me see a couple. Next one, do you think the BMPs for SMZs in the forest industry need a serious update? I think that many of those are very effective. I think that, you know, in places like Alabama, where I am, we'd like to see a little more rigor probably in the implementation rate of those BMPs. That would be very good. I think in general a lot of those are very good, but I'm getting ahead of myself. That's the topic for the third seminar. So I'll cease and desist on that and let Mike also get into that with you.
Okay, and Graham, we're going to continue with some of the questions here, but we're going to push out the link for the survey, the post-webinar survey and the quiz questions, so people can go through that. Hopefully you'll see the link coming up online there on your screen. I'll also paste it into the chat room, and Eric did as well. So we'll just continue with questions and discussion. It sounds like things are going very well. Go ahead, Graham.
I've lost my view of the chat room. Not sure how to get back there. I guess just...
Okay, let's see. There was one up here. I'm not sure if you caught. It was something about are stream buffers enough to help this problem, or is it more of an urbanization problem? And that came in from B. Sadazan, and I'm not sure the particular problem that was being discussed at that point.
Yeah, if the water, the urban water, urban runoff moves through those buffers, it would definitely be a great help. Many of the engineering solutions are designed to get the storm water, the runoff, away from, say, residential areas as quickly as possible, and so it's channelized flow many times in concrete runways. And so that water would not go through the buffer. It would bypass it. And so the buffers would not be of much help in many cases because of the approach used to export that water as quickly as possible. But if you can get the water, if it's allowed to move in more or less in sheet flow, that's an exaggerated term, through the buffer, it would definitely help.
Okay, and then I'm not sure if you're seeing these last two, but
No.
three. Are there urban forest additions that would help offset nutrient and sediment inputs?
Urban forest additions? Give increased urban forest cover?
That came in from Ann Hairston Strang. Maybe she can ask or provide a little bit more feedback on that. Oh, maybe your browser's in the way. Check to see if your browser's in the way, Graham, to see if I think we pushed out the survey
oh yeah, okay,
website.
I got you.
There you go.
Yeah,
okay.
You're right. Okay, let me go up here and look for that one. Are there urban forest additions that would help offset nutrient sediment inputs? Well, if you have like vacant lots, and those could be converted back to urban forest, that would certainly, any addition there could certainly have an effect on reducing the very unstable hydrology, and if you can reduce the runoff velocity, there might be a reduction in the material that's picked up and moved in the streams. Basically, in a highly urbanized area, lots of impervious surface, whatever's on that impervious surface is going to go in the stream because of the high rate of runoff. So it depends on the magnitude. If you could make, I would say, a significant addition through reforesting vacant lots, certainly be worth a try. And then I've got one down here. Is one composition of forest more efficient at removing contaminants? Wait a minute, it jumped. Than another? Absolutely. If you have species of trees that are rapid in terms of that have large nutrient demands, annual nutrient demands, those in buffers, again, if the water can contact those buffers, something like eastern cottonwood, which is very greedy and demanding for nutrients, compared to something like a pine, which is less demanding, but the assimilation capacity is tied to the species. Any other questions?
That might have been it. And if you are having trouble with that link, I think if too many people are trying to hit into the survey link at one time, it might be very slow to load. So there is the link. You can also cut and paste that link that both Dr. Taylor and I put in the chat window. If you need that again, I can cut and paste it down below.
If anybody would like to contact me with additional questions, I'd be more than happy to talk with you.
Great, Graham. Thanks. Can you type your email address there in the chat room, maybe?
I will certainly try. Let's see.
Okay.
Okay.
So excellent presentation. This will be archived as well at forestrywebinars.net, and we hope that you all enjoyed this and look forward to seeing you on the next. We've got several other webinars coming up on all three portal sites, the bioenergy site, the conservation site, as well as the webinars site, the forestry site. But we do have one, the next one in August 6th, application of forestry best management practices for water quality protection. And that will be Dr. Michael Aust from Virginia Tech University. That will start at 2 p.m. And we hope to see you then. So Graham, thank you very much.
Thank you.
Dr. Taylor, do you have anything else to add? Are we good to go if people can get through their quizzes? If not, don't hesitate to contact any one of us. I'll put my email address in there just to make sure.
Bill, if you could add my email address, I'm having trouble getting it in. I'd appreciate it.
I'll be happy to, yep.
Great. Thank you very much. Thank all of y'all.
Take care now. Yeah, quick question. The comment, there was a request for the PDF version of the presentation made available on the website. And Graham, I'll be happy to load that up there if you're okay with that.
Absolutely, absolutely.
And Eric says those are always made available on the website too. So we're good to go. Take care now.
Right.
Thank you, Graham.
Thank y'all. Bye.
Bye-bye.